Hello everyone. In this session, I'm going to discuss about the beta ratio of filters. As in the previous sessions, I've discussed the different types of the filters and the function of the filter. As we know, the function of the filter is to remove the contamination particles from the hydraulic fluid. And here, the one of the method of the rating the filters based on the size of the particle that can trap into that filter. That I am going to discuss by taking this one. Firstly, the filters are rated according to the smallest size of the particles they can trap. A filter with a nominal rating of 10 micrometer is this supposed to trap up to 95% of the entering particles greater than 10 micrometer in size. That means nominal rating is this is. The nominal rating means here in this one 10 micrometer nominal rating if it is given to the particular filter, it will more than 95% of the entering particles which are greater than the 10 micrometers are trapped. Then next we are going to take the beta ratio, and that is the another method of that is whatever the grading of the this filters is there. Okay, that rating of the filters we are going to carry out. By mathematical definition, the beta ratio equals to the number of upstream, the before the filter particles of the size greater than n micrometer divided by the number of downstream after the filter particles having the size greater than n micrometer, where n is the selected particle size for the given filter. Here the 10 micrometer nominal rating what we have taken, that n we are going to take. The 10 is the n here. If you take that one, the before how many number of particles greater than that size are there to the number of downstream particles greater than that size given particular size. That we are going to take in terms of the micrometers. That beta ratio in the form of ratio if you write number of upstream particles greater than n micrometer. Example, we can take the 10 micrometer. The number of upstream particles which are greater than 10 micrometer are there. Okay, that will take in the numerator. In the denominator, number of downstream particles of size greater than again n micrometer. This ratio, whatever is there, that we can call as a beta ratio. And the beta ratio, what means what, and what are the different, that is the beta ratio values we will take. Now, the beta ratio of 1 would mean that number of particles above the specified n are trapped by the filter. No particles are above the n specified n are trapped by the filter. That means the number of upstream particles what are there which are greater than n micrometer equal to the number of downstream particles above the that n micrometer size. Therefore, the both at the upstream and at the downstream both are same number of particles are present. That's why n equal to 1 means no particles above the n are trapped in the filter. A beta ratio of 50 means the 50 means that the 50 particles are trapped. Okay, that is the number of particles means 50 particles are trapped for every one that gets through. Okay, out of that, the number of particles what are passing through that one, out of that 50 particles are trapped into that one. Okay, remaining will be passed through that one. Most filters have the beta ratio greater than 75. Now, what are the practical application? What the filters we are using in the hydraulic system, which are having the more than 75 beta ratio? That means the 75 particles are trapped through that filters, okay, through for the everyone that can pass through it. And the beta ratio is having the efficiency relationship with the beta efficiency. The beta efficiency can be written as number of upstream particles minus of number of downstream particles and number of upstream particles. Means here this difference what are there, number of upstream and number of downstream particles, difference divided with the number of upstream particles, that means number of particles entering, and that ratio, whatever is there, we can call it as a beta efficiency. And this, whatever the size are there, those size will be remain same. Only numbers we are going to consider there. Then the beta efficiency having the relationship beta ratio that I have written here, 1 minus of 1 by beta ratio. The beta efficiency is equal to 1 minus of 1 by beta ratio. How that nominal rating of the this whatever the filters are there, and also the beta ratio of the particular filters, how those are taken, and based on that how we can rate the filters we have discussed in this session. And we will discuss the fluid flow systems in the further sessions again. Thanks for watching. If you like, share, subscribe and comment.